Bismillah and Assalamualaikum. My name is Umar Iqbal Al-Bruni bin Muhammad Adnan. I will be a presenter for this project. First of all, I would like to greeting for my final Associate Prof. Ahmad Kamil bin Hussain and I am Dr. Wan Emily bin Wan Abdul Rahman. Thanks and I appreciate for listening this video. I also like to introduce my supervisor, which is Dr. Fedawati binti Rashidi Wong, and my co-supervisor CHM Dr. Yong Sun Kong and Encik Muhammad Firhan bin Moni. Uh, so, for this project, I will present about the development of recycled polypropylene and agriculture waste like Husk blend composite for 3D printer filament. Okay, for project summary, as we notice, the growing amount of plastic and food waste in the landfill and the ocean has become a serious problem around the world. This problem from the development of sustainable 3D printing filament manufactured from recycled polypropylene waste and rice husk produced from agriculture waste, which has been pursued actively to form a circular economy and reduce the environmental issues. For problem for this project is the weaker interfacial bonding in the composite uh, between recycled PP and rice husk may degrade the mechanical properties. So for this project, we study about the interfacial addition between recycled PP and RH as a 3D printing filament. So for this research, 5 specimen tests will be tested with different fiber ratio, which is we have 0, 10, 20, 30, 40%. So mallet and hydride grafted polypropylene will be used as a capitalizer between these two materials. So the project will be begin with selection material and then will be clean, grind and dry process and before it be extruded to the extruder. Then the rheology, tensile, impact and SEM test will be conducted to determine elongation, tensile strength, tensile modulus, and so many others. Okay, what is the problem statement for this project? Okay, for the problem statement for this project will be found in 4 papers, which is we have the degradation of mechanical properties between cycle polypropylene and rice husk from net RPP because of the absence of chemical bonding between RPP and RH and low dispersion of RH and RPP metric due to the large difference in the surface energy of the recycled PP and RH filler. Next, we have a semi-crystalline recycled PP. Plastic tends to wrap and shrink rapidly when the part becomes curved and unstick from the printing platform and making printing difficult. Furthermore, the poor interfacial matrix addition between polyester fiber and matrix as well as a high level of porosity which could be caused by contaminant decomposing with the recycled material during the manufacture. And lastly, the moisture content causes the lower addition between the filler and the matrix due to the water pathway in the composite. Okay, for the objective. For objective, we have 2 objectives. First, we have to determine the rheology properties and the morphological structure of recycled polypropylene and rice husk composite with the mallet and hydride grafted polypropylene as a compatibilizer. Second, to determine the tensile, structural and impact properties of recycled polypropylene and rice husk with the mallet and hydride grafted polypropylene as compatibilizer. Okay, scope and limitation of the project. 5 specimens with different ratio will be tested in this project. 4% NFBB as a compatibilizer will remain constant for all samples. The material will be collected in Subang Recycle Center in Subang Bestari and Persatuan Peladang Kebangsaan PBK in Sungai Besar. So the specimen follow every standard of the test. Review. I have a research about various filament in the market where the most of the material is from filament plastic and plastic. For my project, I have a study about recycle of plastic as the material for 3D printed filament. So this slide show three papers that show the recycled material plastic can produce a filament for 3D printer. Even though have a degradation mechanical properties but still can be used for filament. Because of recycled plastic can occur degradation in mechanical properties in the composite, there are methods make material filament with similar or better than in the market by mixing recycled resin uh, with the virgin resin in the various ratio, or blending with other polymer material, or adding a natural filler. As we know, the plastic is from polymer matrix base, while the natural fiber is act as a filler in the composite. There are 8 natural fibers to reinforce the plastic as a filler in this project that we study for compatibilizer. Compatibilizer is a binder between first material and second material to form a good or excellent in addition in composite. So there are three papers that I use for show that plastic and rice husk with the compatibilizer given an excellent result. So therefore for our project is we decided to use recycled PP and rice husk with a MAPP compatibilizer for our project to be a composite for filament 3D printer. Technology, we begin with the material preparation where we collect, we blend, we grind and we dry and we mix for this process. And then we do a rheology test where we determine the catalyzation of the composite. After that, we do extrusion process using a 3-screw extruder machine to extrude our material to become a filament. So for this project, the filament that we targeted is 1.75 plus minus 0.06 millimeter. After that, we do a 3D printing process where we use a 3D printing machine to print our specimen in form of dog bone. So to be tested for be tested. So and then we do a mechanical measurement, and then under mechanical measurement we do a three testing, which is tensor test, flexural test and impact test. For the scanning sorry for the morphology measurement, we we use a scanning electron microscopy machine for this determination, and then we analyze the data and we come up with the conclusion. Okay, this is example of the machine that we've used and the specimen that we form. So for the tensile properties, we use a ASTM D638 standard. For flexural properties, we use ASTM D790 standard. And for the impact test, we use ASTM D256 standard. Okay, for the expected result. For the expected result, we do a chain modifier to prove the structure strength and the intermolecular bonding. So by this result, that prove the rice husk, CPP and MAPP can be formed a good composite to make a filament 3D printer. Project plan. For this semester 7, we do electricity review and research methodology and proposal writing. And for next semester, we will do a collection material. We will start with collection material and material preparation, ecology test, extrusion process, 3D printing process, tensile test, flexural test, impact test, and stem test, and writing the proposal. writing the thesis. This is the reference list that I use to refer as my reference for this project. So, thank you.